Welcome everyone to NSTA Web Seminars, where you can find live interactive learning at your desktop. My name is Bryn Slate, Web Seminar Program Coordinator at NSTA, and I'm moderating tonight's program. Joining me from NSTA headquarters is Jeff Lehman, who is here available to answer your technical questions during tonight's program. Tonight's seminar is called Climate Change Here and Now, U.S. Forest Service Research Websites, which model potential future climate change and changes to bird and tree species distribution. And our presenter is Vicki Arthur. Welcome, Vicki.
Thanks, Bryn. I'm glad to be here with you. You ready for me to start?
Yep, take it away.
All right, I sure can. Well, welcome to all of you. It was real interesting to see where you are across the country, and I see that Emin is joining us from Turkey. So that's pretty exciting too. So thanks everybody for joining us. And when I see the spread of age groups that you teach, I think that you'll find that before we're through tonight, we'll have something for everybody, and that you'll be able to adapt these tools, these resources to help you really at all those ages. So I'll start out by just saying how excited I am to share this stuff with you, because it's really important that educators start to tackle climate change with their students, and I have some tools to share with you that I think are just unsung heroes to help you get there. So let's jump in. So I'm very excited about sharing these with you, and I'm very excited because I think some of these tools that the Forest Service has will help you bring the climate change issue home. And the importance of that is, what does it mean to me? And so, obviously when it applies to the place that you call home, it's easier for anyone at any age to relate to than maybe thinking about a polar ice cap someplace else than where you live. So I think that's a huge strength of some of these tools. I'm a conservation education specialist for the U.S. Forest Service in Washington, D.C. So that's a little bit about me. Okay, let's get down to it. I don't do this alone. Backing me up tonight are a couple of the scientists who have worked with some of the websites, well, specifically the Bird and Tree Atlas that we're going to look at a little bit later. And so I have with us Matt Peters. He works for the Forest Service at the Northern Research Station in Delaware, Ohio. And Matt is our GIS guy. He's done his undergraduate work in GIS at Ohio University, and he has a Master's of Science in Applied Biological Sciences from Arizona State University. And so Matt's here to watch his young baby daughter while answering any questions that I can't handle. So Matt, you want to say hello to the folks?
Hello. Yeah, I'm like Vicki. I'm also surprised that so many people are interested in our work. So it should be a good webinar.
Thanks, Matt. And also, because Matt's juggling his baby daughter, we also have Steve Matthews from the Forest Service, and Steve, I understand, is the author of the Bird and Tree Atlas. So our scientists are interested because they didn't design these tools with you in mind, and they were designed for land managers, actually. And so this is a new realm of, of their interest to see, gee, I like to see how these educators like this. So we'll collect some feedback from you tonight as well. But I think these are just dynamite tools ready for you to use in your classrooms and outside, by the way. Okay. So thank you, Matt and Steve. Okay, so we have a first poll question, and here is the premise of our question. Would it help you to be more effective in teaching climate change if you had education resources that brought the issue closer to home? So, now that you're experts at poll questions, give it a go.
Okay, everyone, and your poll button should now be active. You can select A through Z to let us know your response. And I'll give everyone just one more moment to answer before I lock the responses and publish them to the whiteboard so we can all see what the response is. Okay, Vicki, so there are the responses to the poll.
Okay, very helpful. Thank you. So, most of you think that would be very helpful, and if you add the people who think it would be critical, we've got 52% of people say, this is a good thing. So great. Thanks for that feedback. Okay, so here is the website of the Intergovernmental Panel on Climate Change. And why I stop and pause here to show you this website is I think it's actually very useful. The Forest Service has been, you notice that the title of our webinar is Climate Change Here and Now. And the Forest Service has been researching climate change for 20 years. It is very aware of measuring a change of climate and its effects on tree species especially, and other vegetation and other changes to the environment. And so we stand behind the fact that this is going on, has been measured, and the science behind these, recording these changes. And so if you look at this website, you'll see that for 20 years, other scientists as well have been documenting climate change. And so some of the things that as the public is just becoming aware of, in the science world have been clearly documented. And our Forest Service, 13 of our Forest Service scientists proudly shared in the Nobel Peace Prize for their science contributions to the 2007 climate change report. So we're not afraid to say climate change. And these tools will help you as well. Okay, so the first research website that I want to show you is called TACAMO. And that stands for Template for Assessing Climate Change Impacts and Management Options. And that goes back to that a lot of these tools are developed with the land manager in mind. But there are all kinds of things for you as an educator here. And on this website, you also see let me grab my pointer. You see these buttons here give you some nice, concise fact sheets on topics such having to do with climate change in forests, such as insects, diseases, invasive plants, wildland fire, and then there's also a climate change button. So that's there for you. But we're going to focus on this TACAMO. Okay, so what this has, not all of it is friendly to education, and you can get lost in this, but I'm going to highlight the things that are friendly to education that you can find in here. And one of the things that I like is that it's basically made up of a report function for regions of the country. So you can hit the report function, let's say, for the Southeast, and pull a report for your region. And then there's some things of use here and off of this report. And one of the things that I liked was it has information about a concise description of different carbon emission scenarios and what they represent. They're given in these codes from lower to higher. And then there's a nice, concise explanation of what these models represent. And then the other piece is a GIS mapping function. And, well, also before we leave the report, you can pull precipitation maps and temperature maps for the country that give you a visual like these maps. And so we're looking at historic monthly temperature average as compared to a projected average. And I'm sorry, I think on this slide it's not showing up. I think it's up here off of our screen of what the year projection is, but this is into the future. And you'll see here that the average for an earlier period of time was 11 degrees Celsius, and it's going up 2.2 degrees in temperature, and there's change in precipitation averages as well, and you can see which areas of the country are changing. So that's one kind of visual. But what I'm going to show you next, I think, is much more meaningful. Okay, so what's cool about this is you can go to the GIS viewer in this website, and what you can pull up, I did this for Indianapolis because we were just at the National Science Teachers Association conference there. And so I used Indianapolis, and all I had to do was take one of the handy pointers and click on Indianapolis, and this is just like a Google Earth map. You know, you can zoom in on your house even, your street and your house, and you can click on it, and then you can pull up, this is a little fuzzy, so forgive us with that, but what my point is, I think you'll be able to see, is you can pull up a graph for temperature and precipitation projected. These are years to the year, I believe, 2090. And over here, you click on the carbon emission scenarios, and it goes low to high, and it's got them by their code names, which you could go back to that descriptive piece and see what they are. But basically, it's the low to high computer modeling of the the potential future of temperature and precipitation for this dot, which could be your house. Okay, and here I pulled one, we're getting closer to the street level here, and I pulled one just to contrast. This is the precipitation graph, and we just clicked on a low and a high to compare those comparisons, and you can see there's a lot of difference in what those models are predicting for that year 2090. And I think that's interesting for the students to know, because I think this helps them be literate with understanding computer models and graphs. The interesting thing going back to the temperature graph is, the point is here, I think, that even though these different emission scenarios from low to high showed them ending up in different places in the year 2090, they all show a common trend of increase in temperature. So that's your point there. So this is pretty cool. But the day that we were doing the NSTA conference in Indianapolis, on the front page of USDA or USA Today was a story about how kids were getting out of school early because they didn't use any snow days this year, or not as many snow days. And so kids from throughout the country are getting out early. And then you show that your kids this graph, and it says, yes, you know, Johnny, the temperature is going up at your house. You know, how does this elicit any kind of anything but joy? So we have to take it to the next step, and that's where we're going. So temperature's going up, precipitation is changing. You can show that with these. Okay, so we're going to pause from showing you that piece and take your questions. And also, if you like that, I would like to know a little feedback on, you know, what you can chat, or I think there's a clapping or something, a button like that.
Okay, everyone, so now's our first question break, and if you have any questions for Vicki right now, please type them into the chat box, and we'll make sure she has a chance to answer. Vicki, I also wanted to just ask if you could speak a little bit louder into your phone line. Several people are having a little difficulty hearing you, and I know that you're on the teleconference line, so if you could just speak up just a little bit, that would be great.
Okay, is this a little better? I moved it closer.
Okay, yeah, that would be great. And we have our first question or a comment from Caitlin that she's on the GIS viewer, and she's wondering if there is a quick way to get to her zip code.
I would say, Caitlin, just get in there and play around. It's not going to come to you right away, but the way that I learned how to use this thing, the scientist, I called him up and I said, you know, I think this has got a lot of education potential, and would love to use this with educators. And he said, well, great, you know, go for it. And it's got this great GIS layer to it. And he said, and I was expecting him to babysit me through the thing, but he just said, go try it. And so that's sort of what I need to encourage you to do, is just play with it so you can figure out how to just zoom right in. And we're going to do a little piece where you get to play online. I'm not free to, like, I don't think I want to part from the slideshow just yet, but we will have an online portion where we could just freely play around with things.
Okay, Vicki, and then we have a question from Leslie here, wanting to know if this is a correct recap of how to use it. Choose a location, a time frame, and an emission scenario that I want to apply, and then run the simulation. And then also wants to know, can I change the time frame, or is it one set time frame for 2090?
Yeah, it's one set time frame for 2090. That part I can answer from here. I guess I just want to take big picture questions. As far as that goes, the specifics I'm not able to answer because I'm not in the website and looking at the piece that you're playing with. So sorry, but back to that. I just need you to play with it, and then we can revisit live on the web at some point. Okay. All right, great. I'm going to keep moving because I've got more excitement for you. Okay, so here's what I've been talking about. So you remember I said the kid at this point is saying it's going up 2 degrees, and that sounds pretty good to me. Who wouldn't be pleased to have summer, more warm weather all the time and all that? So then we want to take the next step. I think this piece does it nicely, which is showing, okay, so what, 2 degrees warmer, but what does that mean in terms of in this case, tree and bird species and changes to their suitable habitat? And so we have the atlas. And here's the website for it, and I'm going to walk you through it. And let's see. But first I want to tell you about it a little bit. I think this website has the potential to demonstrate a lot of your STEM education pieces. And so through this website, I propose that you can demonstrate how climate change can affect tree and bird species habitat distribution. Clearly, it does that. You're able to model the potential impact of these different carbon emission scenarios on the bird and tree suitable habitat. And you can also get to things like how computer models work and how data drives those computer models. Take the mystery out of that. How computer models are tested for reliability, and so we're giving an example of that with this bird and tree atlas. So pretty powerful stuff. So here's just a cover slide to show you some of the things that the atlas can do. And so here I'm showing a screen for a bird species, the tree swallow. And there's buttons to push, and we'll play with some of those. And so, and there's pull downs. So you have the one drawback of this, it's for the eastern United States only, even though it does have species that you will recognize on the West Coast and can relate to and see, you know, and as I said, to back up to that demonstration slide, it demonstrates principles that transcend the map, and so I think it's useful in that sense too. So in this case, we pulled up the tree swallow, and up here are links to different natural history links of value for each species, and like you can go to links that show about this species' natural history, and links to Cornell's website, and has some habitat information and so on. So then you can go to to a map and show where the bird's habitat is currently, and it's on a scale from the pink is more abundance. And so you can see currently where the range of distribution is for that bird species. And then you can go to a pull down from a low to high emission scenario, and you can see there's a potential for quite a different picture for that bird species in the future, especially shown in contrast with now and the model of high emission scenarios. And so the high emission scenario, by the way, I haven't really touched on this yet, is like an emission scenario for business as usual, with the amount of population growth, carbon emissions trending upward and such that we've got right now, whereas a lower emissions scenario is when we make some changes to the kind of energy we're using and take conservation measures and so on. Okay, so this is showing the contrast, for instance, for a tree species, the northern red oak, a contrast between a low emission scenario and a high emission scenario. And the red is where a pixel is showing that tree is more prominent in a stand of trees represented by a pixel. And so you can see there's more of the red and the next one down. This is high and this is low. And this is, white is absent completely. So there's a difference in abundance here shown between a high model and a low model. So you can show that kind of thing. Okay, so I've got a short introductory video that is on the homepage of this website, and Bryn's going to launch it for us. It's a 4-minute video just to give you an overview.
Okay, everyone, you should have that video opening in your browser, in your whatever Internet browser you had open, and so all you need to do is click that play button once it opens. I'll also post it in the chat in case you have trouble with that.
Okay, so we can go back to the website itself, Bryn.
Okay, Vicki, we're now on the Climate Change Atlas conducting a web tour, so if this is where you want it to be, just let me know.
Okay, let me see how to get back to where you are. Okay, great. I'm with you. Okay, I hope that played well for everyone. It worked for me. And now we ought to all be looking at the home page for the Climate Change Atlas. Okay, so I'm going to take us first to the tree atlas. Set my phone down here. Okay, are you tracking with me, Bryn? I'm on a tree species page
We're not there
here.
yet, but I'll go ahead and click on that so we can follow you along.
Okay, I'll kind of slow up just a little.
Okay, now we're on the tree page.
Okay, so wonderful. Okay, so here we have, first off, when you enter the tree piece of the atlas, you get a list of, let's see, can I have a pointer? Can you see my mouse, Bryn?
No, we can't see the mouse. You're just going to have to navigate us through it.
Okay, I'll talk you through it. So you have a list of the common names and the scientific names for 134 tree species. And on the left you will see red, yellow, and green circles of reliability. And so it's just like a stoplight. Green means that species tracks well with this computer model and has more reliability. Red, not as much. Yellow, pretty good, but not the best. So that gives you, that shows, I think, the message that the computer model is a tool. It's not the end-all answer. And it recognizes that there's question marks and some data is more reliable than others that come from the computer model. So I think that's a good science point to make here. And so on the right-hand side of this page, you have buttons to push that will help you get to the modeling page. So let's see here. Let's just start to play around. So let's pick a tree. Black oak I guess I'll pick sort of maybe more. I want to pick that northern red oak that we were looking at earlier. Okay, so you can see it's a green light there, northern red oak. So here we go. So up at the top there you see the species information and also some links, some good natural history links to be able to find out more background information about the species. Here I'm clicking on the range map for the northern red oak. And so it's got a dark red line that's circling the range where it's currently known to exist. And so this is collected in what the data that backs up this current model condition is the forest inventory analysis. And so we have samples of on-the-ground data to verify where certain species are found. And so that's what largely what this is based on. Okay. And so we're going to go back in the browser. Okay, so what we can do on the right here is to look at these changes with a changing climate. And so let's do some summary maps because that's a good way to show you the whole thing. So what we have here when this opens for you is northern red oak distribution. And here it is shown what we know is on the ground currently, a good representation of what's on the ground for that species currently. And then here, I'm not sure RF, I forget, but let's see, we can look up the acronyms here for the models. That might be one for Matt to fill us in on. But here we're going from current to Hadley High, the high emission scenario, and you see not as much abundance of the northern red oak. The low, there's still areas of abundance, but not so much in the southern portions of its range. And these last maps are an average of the high models versus an average of the low models. So you are able to see different representations of the models. This is a current representation of what's on the ground again versus those high and low averages. And one thing that I think really helps make this easier to see
Hi, Vicki. We lost your audio for a moment. Are you still there?
Yeah, can you hear me?
Oh, yes, I can hear you.
Oh, good. Sorry about that. Okay, so I'll keep talking while it's loading. This is something that I think visually is quite helpful in trying to interpret these maps. Oh, I lost that. Go back. Let's try again.
Vicki, which map are you currently looking at?
I'm looking at the abundance change map.
Okay, we're with you now. We're with you now.
You guys have that? Okay. Okay, glad to hear it. Okay, so I plug in, I've got current. Okay, so this I think is fun. Animate scenarios. Okay, so I've got in here an actual known on the ground current condition for northern red oak versus the Hadley High, and you can dial that up in those upper tab buttons, and then you can animate it. So right there you see what is the abundance now versus into the future. And this is going to the year 2100 with the high emission scenario. So it shows you that the red is what is on the ground now, is abundant occurrence of the northern red oak versus how it could become so much less abundant and is clearly affecting many areas of the country as far as dropping out completely. So yeah, I think this would be interesting to kids. And okay, so I've played with that a little bit. Let's watch a second short video, and then we're going to have you guys play on your own with this, and I'll show you some of the finer points also. So, Bryn, if I could have video number 4.
Okay, no problem. I will load it up for us, and it will open again, as last time, in a new window of your browser.
Great, thank you.
Just remember to click play, everyone.
Okay, folks. So hopefully you've returned and we're pulling up the website again. So there's something on the website that I want to show you which makes the point of how computer models are tested. And it returned to me after watching the video just now myself about the RF model that we were looking at. So I'm just going to cruise right back. To Northern Red Oak. Click on the abundance change. Wait while that loads. Okay. So how do we test the reliability of a computer model? How do we make sure that it's reliable? Well, the way that you do that is you take what is known on the ground, and in this instance, let me see if I can break this down for you in terms of this model and trees. So on the left, we have the current conditions, and that's been determined by walking the ground. There's some satellite photo work there, but it's the known conditions of where this tree is found. And then over on the right, I'll scroll over here, is taking this model and using it as a predictor of what's on the ground now. So you're testing your model by seeing if it matches today's scenario on the ground. And so I hope that's helpful in helping people figure out how we test the computer model's reliability. So how you can demonstrate that. And so what they found is it's not an exact tracking of the real conditions, but it's scientifically it's tracking enough to qualify for being a reliable source of information. So there you have it. I wanted to show you that. And some of the finer points you saw at the end of that video, how you can go as deep as you want with this. There's data sets there for you to work with if that's your thing. If you're looking at a statistics class and you want to learn through using real life data, and so you have those tables where you could get in quite deep. These niche maps to me are kind of interesting because, truthfully, we're all afraid of graphs, and everybody gets a little freaked out looking at a graph. But like, for instance, on this, here's a different way of interpreting data on a graph. And here we're looking at the ecological niche for Northern Red Oak. And you find that if you intersect an average temperature of 10 degrees Celsius with an average precipitation of 1,000 millimeters of rain per year, then that is the conditions where you find this species. And so here's a new way of reading that, and understanding that graph. And once you start to look at that, it takes the mystery out of that. It's really not as bad. So it gives you the tool of different ways of displaying data and being able to explain that to the students. So, Britt, if we go back to the PowerPoint, I think we're at the point where we want to give people a chance to try this for themselves.
Okay, everyone.
And I think we're going to give you 5. Go ahead, Brent.
Okay, we will open up the web tour one more time, and I will put a timer on the top of the board. But everyone can feel free to click around and explore on their own. And when the timer goes off, we will come back for a question break. So just make note of your questions, and Vicki will answer those when we come back.
And Matt, looks like you're standing by. Were there any points you wanted to make that I missed while people are playing around with the website?
Well, I mean, there had been some questions that I was answering in the chat. There's one right now about the little boundary. What does it mean? So just to give you some background, in the 1970s, there was a researcher with the Forest Service, Albert Little, and he, along with a bunch of colleagues and experts within the field, went ahead and mapped out the boundaries of tree species for the entire, I think, North America. And so we use those range boundaries as a way to have a historical baseline of where we know tree species are to be. And then we use our models to then project within the eastern U.S. how well our models are actually doing compared to a known range of the 1970s. So that's just a little background on the range maps versus what our models are actually predicting. And so you had also asked the question, what does RF mean? RF is our shorthand for random forest. Random forest is a regression tree analysis model. And if you're not really familiar with that, you could just think of it as a dichotomous key. So it's a yes-no type of tree analysis. And so we throw all of our predictor variables into the model, and it kind of sorts them out into bins, if you will. And it's basically asking, is the temperature higher or lower than this? If it's higher, it gets put in a certain bin, and that's how we come up with our predictions there.
Okay. Okay, so were there any burning points you wanted to make that I didn't hit on?
Just one thing to keep in mind with our models and just, I guess, models in general is that they're all at produced at a certain scaling. So our scale is 20 kilometer pixel. And so while it might be nice to zoom into your backyard and kind of look at where your pixel falls, you know, the reality is that these are all aggregations, so it might be more appropriate to look at a larger range, and so maybe your county or state to see how that kind of fares out, rather than getting down to the nitty-gritty, saying that, well, my pixel or my backyard is going to be slightly warmer than the pixel next to it, and you know, the reality is that the climate doesn't necessarily operate on that pixel basis.
Okay. All right. Bryn, I think we're ready to roll.
All right, and just on time. So everyone, we're going to come back together, and if you have any further questions for Vicki or for Matt, go ahead and type those into the chat box now, and we'll take just a moment, just maybe a 1-minute break to see if we have any questions before moving on to our next part of the presentation. It looks like Catherine wants to know who did the boundaries.
I think, Bryn, since it's quarter to 8, I would like Matt to cover those specific questions in the chat bar, and I'm going to keep rolling, if that's all right.
Sounds like a great idea.
Okay. All right, so I really hope that you see some usefulness in this website, and I also wanted to give you some more ed resources, and if I didn't lose my elementary folks, I want to give you some things that are more adaptable to the younger kids as well. So we have an interagency group. You can see the agency's logos here who participated. We did another regional educational resource for you to help bring that message home. And it's a climate change, wildlife and wildlands toolkit for educators. And you can click on your part of the country and tie to other wildlife species and have a case study. I did the Northeast forest, for instance, and we focused on woodpecker species and how climate change using the atlas actually is predicted to have different effects on different species there. And so you have activities also tied to this toolkit. And I wanted to mention that for parts of the country that are having a harder time bringing up the climate change topic, our partners, our current partners in a second piece to the toolkit that's coming, we also have brought in a human health piece. We have National Institute of Health, NIH's Ecosystem and Health Services Division has joined us to make that link from climate change issues to human health. And so I think human health is something that kind of transcends politics there and can help you approach the story that we all want our kids to have a good quality of life and to be healthy. We want our grandkids to have that same thing and so on. So we're going to have some good tools for you coming in this edition of the toolkit that tied to human health as well. There's more resources there. Okay, elementary folks, sit up in your chair. Here we go. We also have an iTree program, a software program that is developed to tell you the value of trees and what the services they provide for us, and it actually puts a dollar value on those services that a tree provides, and quantifies those services. So price tags were put on trees when this park bond was being voted on, and as the legislators entered their Capitol building, they could see the price tags of the services that the trees provide, and the bond was voted yes. So valuable stuff, first developed for urban forest uses, city planners to help manage and value their trees. We have a curriculum developed for this software, but it's really very basic. I'll show you how it works. There's a tree calculator, and you put in the type of tree, the diameter of the tree, and there's a pull down for a school building would most closely relate to a small commercial business footprint. So you have your life sciences here, you have your math lesson, and your outdoor ed. So you're outside measuring your schoolyard or your community trees. You enter that data into this calculator, and your first screen, in this case we entered a pretty small maple tree and 12 inches diameter, and so we get a printout of the actual dollar value of the services that this tree provides, and it projects onto, as the tree grows larger, how the benefits will grow. And here we have pull-down menus for this overview screen for stormwater value, property value, energy, air pollution, and my favorite, how much carbon does this tree you just measured sequester? So here's an example of the stormwater pull down, a very concise description of how this tree eliminates 3,406 gallons of stormwater runoff in a year, and why that's important in terms of pollution, in terms of reduction of flooding, flash flooding, and so on. You get the same thing for the air quality. It tells you what type of pollutants are being filtered by this tree and how much. And the 12-inch red maple is reducing the atmospheric carbon by 338 pounds per year. And what is the significance of that number? Well, an average car is driven 12,000 miles per year, generating 11,000 pounds of CO2 every year. And it talks about an airplane flight across the country and how much carbon comes from that. And so then it compares that to what the tree sequesters. So I think that's, hugely valuable. You might wonder what avoided means. If that tree is shading the building, you're using less electricity for air conditioning, let's say. And so you're avoiding, on average, using this much electricity and generating that much carbon, as well as the sequestration amount. So that's valuable. So I think this is great. There's lots of background information for you, and you can also use a CAD design program on this to block out the footprint on a Google Earth map of your building, and then click on the exact tree that you measured, and it gives you an exact, the location of that tree in relation to the building. It gives you the energy figures in a more exact way because of the relationship to the building and the aspect. And so with your kids, you could if you're going to do a tree planting project, you could have the kids research what type of tree would get you the most carbon sequestration, where to plant that tree to get the most bang for the buck as far as shading the building and that kind of thing. So I think this is hugely a valuable tool and would translate from elementary to beyond for any of us to start to answer that. So I would love to know which of these tools you think you could grab and run with in your classrooms, and so I'll let Bryn tell you how to answer the poll.
The poll buttons are now available, and you can select A through E to let us know how you might be using the Takamo tool. Okay, one more moment.
And that's the tool with the GIS map where you clicked on your house and you could pull up temperature and precipitation graphs for the different carbon emission scenarios.
Okay, it looks like we've got almost everyone's response on this one, so I'll lock the responses and show it on the whiteboard. It looks like most people are going to give it a try, Vicki.
Wonderful.
And how about the bird and tree atlas? You can go ahead and select your answer now for that one. Okay, looks like most people have voted, so I'll lock the responses and publish those to the whiteboard. Again, it looks like it's pretty exciting to people.
Very glad to hear that.
And now for the iTree benefits calculator, go ahead and submit your answers. Okay, thank you to those who have responded. I'll lock their responses now and publish them to the whiteboard. All right, it looks like a lot of people are going to try out the iTree.
Yeah. Yep, that's a winner. Oh, I'm glad to hear it. Well, that's excellent. I know the other two are a little bit more daunting, not so much for the younger kids, but I hope you, with the emphasis on STEM, I think that there's a lot of potential there, so I hope you will jump in and play with it and see what you think. Become more comfortable with what you're looking at, and you'll have our emails, our phone numbers. We'd love to hear from you to get some feedback on your use of this, and if you have questions, we'll be more able to thoroughly, answer your specific questions. Okay. And so there's my contact information, and please let us know how it goes. Well, thank you, everybody.
Thank you, Vicki. And thank you, Matt, too. We really appreciate your effort and time spent on this, Vicki, and we appreciate Matt being online to help answer questions and give his perspective working on the Atlas. Everybody go ahead and give Vicki and Matt a round of applause using your emoticon buttons. I'd also like to thank the sponsors of tonight's program for sponsoring our work tonight. Thank you. Just a reminder to visit the Learning Center, where you can register for upcoming web seminars and access over 6,000 resources for teachers. And a thank you to the administration of NSTA for supporting web seminars. And here's a reminder of our upcoming programs on May 1st, Developing Visual Literacy in Science K-8. On May 2nd, NSF, Natural and Anthropogenic Climate Impacts as Evidenced in Ice Cores. And then on the 3rd, another one from the Interagency Group, New Climate Tools for Educators. I'd like to thank everyone for participating this evening, and if you're viewing this web seminar on an archive, we hope to see you soon on a live web seminar. Thank you, everyone.